We're given Alex walks east at 3 meters per second, and Bob walks southwest at 4 meters per second. And we want to find the relative velocities, Alex with respect to Bob, Bob with respect to Alice. So first, we draw these. So Alice walks east. So this is velocity of Alice. Bob walks southwest. Velocity of Bob. So then the relative velocities, this is velocity of Bob with respect to Alice. And then the exact opposite would be velocity of Alice with respect to Bob. So let's see, procedure. Step 1, draw the vectors. Step 2 is find components. We need to break the velocities into components so we can actually write them as vectors with I hat, j hat. And then step 3 is relative velocity formula. You just subtract the velocities. So the velocity of Alice is 3 meters per second east. So we can write that vector as VA equals 3 I hat. She's going in the X direction. Now Bob he's going southwest. So if he's going southwest, then we know that his angle is going to be 45 degrees because he's exactly halfway between south and west. So if we break him into components, then that is going to be 4 times the X component, which is cosine 45 degrees in the I direction, but he's going west, so that's negative. And then the J, he's also going down in the Y direction for sine 45 degrees. So we can simplify that, negative 4 over square root of 2 I hat minus 4 over square root of 2 j hat. So to find velocity of Alice with respect to Bob, velocity of Alice with respect to Bob equals velocity of Alice minus velocity of Bob, or Ben, I think is what we call him. So that equals, in the I hat direction, we have 3 minus negative 4 over square root of 2. So I hat is 3 minus a negative, so it becomes a positive, 4 over square root of 2. And then in the Y direction, so we'll have negative, but then there's also a negative there, so plus 4 over square root of 2 j. So if we put in those numbers, that comes out to be 5.83 I plus 2.83 j meters per second is velocity of Alice with respect to Bob. Okay, so just as a reality check here, we see this is a big positive number in the X and a kind of smaller positive number in the Y. So looking back at here, if we're looking from Ben to Alice, that's bigger in the X positive, smaller in the Y positive. So this is a reasonable looking answer. Now, velocity of Ben with respect to Alice is just the exact opposite. VB with respect to A equals negative VA with respect to B. So that is just going to be negative 5.83 I minus 2.83 J meters per second. Velocity of Ben with respect to Alice. And now let's look at a simulation of what this actually looks like. So you can see here, I put in velocity of Alice. First thing is the X component, second thing is the Y component. Then velocity of Ben. First entry is the X component, second entry is the Y component. We'll calculate velocities and then it will give us a visual. So if we run this, see global view, each of their velocities. And then here, relative to A, this is where we pretend that we are observer A. So this is in Alice's view. Bob is running away pretty fast to the bottom left. And then in Bob's view, Alice is running away pretty fast to the top right. So we'll run that again. So this shows what it looks like from each observer's point of view, and then what it looks like in real life.